Okay, so the term V, so I'm going to describe what they are. V, or sometimes referred as U, is known as our cutting speed. And the unit in cutting speed is in meters per minute, or we usually like to correlate in meters per second. Okay. Then there's another velocity down here. That is our VC. Okay. So VC represent our chip velocity. So this is in meters per minute, or it can be meters per second. Okay. Then at the cutting edge, I'm going to draw a horizontal straight chain line. Okay. And this is where we call our T. Okay. That is our T. So the T over here represents the undeformed chip thickness. Okay, the undeformed chip thickness is usually in meters. Okay, and then I'm going to draw a line. Then we draw a green line. Okay, and this green line makes an angle over here known as pi. And this pi is really important. Okay, so this pi is known as our shear angle, and it's in degrees. Okay, the line I've drawn, okay, you can see now, this is where is usually referred as a shear plane. Okay, so remember that we see a shear plane previously, we did, right? We call it a shear plane, but sometimes, okay, not shear plane, we usually call it the primary shear plane. Okay. But sometimes some textbook or some researchers refer this as a primary shear zone. Okay, I'm going to follow them called shear. Okay, because previously when a lot of theory been applied, they usually are not solid mechanics people. So I teach solid mechanics, okay, which is like structure analysis. I realize it's not just shear, it's compressional, but I'm not going to change the terminology. Then we have a certain geometry over here. I'm going to draw shortly. This geometry from here to here, which is our big T. Okay, so big T is our deformed chip thickness. Okay, so this is in the units is in meters. And then we have another angle over here that I'm going to draw. Yeah, that is our alpha angle. Alpha angle is known as our rake angle. Okay. And then we have another angle over here. Okay, this is known as gamma. And gamma over here is known as our clearance angle. Okay. And then this surface is over here is known as our clearance face. Okay. And this surface over here is known as our rake face. Okay. Then we have a certain feature over here. There's triangular light. Sorry. Okay. So this area that I've just drawn is known as secondary deformation zone. Okay. So SDZ is a term that we usually use, or we call the other one is called PSZ, primary secondary zone. Okay. And then we have our this surface over here. Yeah, this surface over here, this interface over here. Yeah, that interface over there, we usually call it, oh, this is messy today. We call it our two-chip interface. Okay, that's our two-chip interface. So if I were to draw this to scale, okay. So this distance is about 250 micron meter. So 2.5 times the thickness of your hair. So I'm trying to put this into perspective. Okay. Then I'm going to magnify this edge over here. Okay, I'm going to draw it. I'm going to draw it big, and I'm going to draw it big over here. Okay, I'm going to draw it big over here. So if you zoom in enough, over here is what we call our R. Okay, so some of you say, Eugene, where are we now? Okay. So this surface over here is our rake face. This surface over here is our clearance face. Okay. And R is known as our cutting edge radius. And the units is also in meters. And then if you were to ask me what is the scale of the drawing over here, I'm going to draw, okay. So this is about 30 micron meter. To just let you see the perspective of scale. Okay. Anything more for me to add? No. Okay. So this is in any metal cutting process. Okay. You see this. Okay. It can be drilling, can be turning, can be milling. You always see this. Okay. So I'll let you guys copy a bit more. Then I will show your YouTube video. Okay. And then once showing you the YouTube video, I want you to refer to this diagram over here. I know this is the first time you're seeing it. And then you'll say, I know what is that. I know what is that. Okay, so I'm going to stay here, and I'm going to hopefully get this to work. Okay. Oh, wrong mouse, Eugene. Wrong mouse. Wakey. Okay. Now I'm going to. No, not like that. Not like that. I'm going to like do this, and I'm going to bring this down. Hold on. Bear with me. Hey, come on, Eugene. Seriously. Okay, I'm going to. So you can see the diagram, and I'm going to do this. Can it go any bigger? Okay. So this is a video that you can see that they are cutting in a scanning electron microscope. Okay, so it is doing it at a very low speed. Okay, so you can see that this is the rake phase, right? Where my cursor is, you can see my cursor, right? There's the rake phase. This is the clearance phase. Over here is my cutting edge radius. Can you all see the shear plane over here, or where my arrow is moving? Yes or no? Right. So how to define the shear plane is over here. The microstructure is not distorted yet, right? Down here at this transition line, okay, the microstructure has been distorted. Okay, so that's where you get this primary shear zone. Okay, it's very difficult to define as it's a line. No, it's not. It's a zone. So what you see over here, you see like white color. You see light color and darker color. So the light color are your ferrite. The dark color are your pearlite. Okay, so I'm going to press play. You can see for yourself what is going on now, right? So you can now understand this figure over here, what you are looking at, and what it means to watch a figure like this. So you can see over here at the tool and the chip, okay, this is where we have our secondary deformation, and you can see a bit of triangular, right? How it's deformed. Okay, so you can see it again. Okay, so this is cutting at a very low speed. Okay, the speed is low. Okay, you can see how it's deforming. Okay. So this is a close up, and what you see over here is a stagnated zone down there. It seems like there's material like not moving. Okay, not moving. I backtrack a bit. Okay, wait. Let me. Oh no, not here. Sorry. No. Come on, Eugene. Wait. Yeah, you can see material like stuck down there. Okay, so today we are going to apply Mohs circle. Okay, we're going to apply Mohs circle to prove to us why is it stuck down there. Okay, why we have things stuck down there. Okay, and the thing stuck down there is a double-edged weapon. It can be good news. It can also be bad news, and how to get it to disappear. Okay. So now, okay, so this is on what you can see. Yeah, the material is still stuck over there. Okay, and you can see all of a sudden when the material start to fracture off. Okay, you see fracture over here. So this is the where my arrow is pointing. It's known as the primary shear zone now. Okay, they like to call it plane, but it's not a plane. It's a zone. So workpiece. This is the newly generated surface. Okay, now we are looking at different tool. Okay, so I think you all observe a lot of this type of effect every morning when you're having breakfast. Okay, what do I mean by or eating ice cream? Okay, when you slice your butter, you see this. Okay, this is like your edge of your knife, and then you push your butter across. Okay, and then you got a curl of your butter. That's your chip, for crying out loud. Okay, and then you can see fracture over here depending on the material. Okay. So now, how this is related in real life, okay? So we understand what this figure is all about now. So how is this related to real life? So I'm going to show you a clip on turning, okay? So turning is a process where the tool is moving in a linear motion the workpiece is rotating. Okay, so so this over here is your workpiece. This